Hello, welcome all. In the previous video, we talked about why BGP exists and how the internet is not a single giant network but a collection of many independent networks. This video builds on that idea, but even if you haven't watched part 1, you can still follow along. Today, we are going to understand one of the most important building blocks of the internet, autonomous systems. Consider this to be some section of the internet. Then these circles can be thought of as autonomous systems. At a high level, autonomous system is a large network or a group of networks that is controlled by a single organization and follows a single routing policy. This organization could be an internet service provider, a cloud company, a university, a government network, or even a large enterprise. What makes an autonomous system unique is control and independence. The organization that owns the AS decides how traffic flows inside the network, which other networks they connect to, which routes they accept, and which routes they advertise to the rest of the network. In simple terms, autonomous system represents a network that can make its own routing decision. Inside an autonomous system, routers typically trust each other because they are all managed by the same team. These routers use internal routing protocols like OSPF to determine the best path within that organization's network. Now, when we zoom out on the internet, we see that the internet is actually a collection of thousands of autonomous systems, each owned by different organizations with different priorities. So, hence, they have different goals. Because of this, there's no global trust between autonomous systems, and that's why internal routing protocols cannot be used across the internet. Let me draw the autonomous systems again. Now, to uniquely identify every autonomous system, each AS is assigned a number which is called the ASN or the autonomous system number. This works like a global ID for networks, helping routers understand where routes come from and which networks traffic has passed through. So these ASNs are actually globally coordinated by an organization known as INA or Internet Assigned Numbers Authority, which ensures that these ASNs are unique worldwide. Let's say in our network we have three AS with the numbers 64,000, the second one with let's say 13,000, and the third one with let's say 59. When you browse a website, your traffic often flows through multiple autonomous systems before reaching the destination. So let's say this is the path that we want to follow. This is the source. We go through here, then we go through here, here, and then we reach the destination here. So this is the source, this is the destination. The path or this path is known as the BGP path, and it will look as follows: AS 64,000 followed by 13,000 followed by 59. Not all autonomous systems are equal in size or role. Some are tier 1 providers forming the core of the internet. Others can be regional ISPs, and some are enterprise or campus networks. Autonomous systems also form business relationships with each other. Some networks peer with others to exchange traffics for free, while others may charge some fees. This is why BGP is not just about finding the shortest path, it's about policy, control, economics, and even stability. So while internal protocols manage traffics inside a network, BGP manages traffics between autonomous systems, allowing each organization to enforce its rules and preferences. So to summarize, an autonomous system is a self-governed network. It has a unique ASN assigned globally. It controls its own routing and policies. In the next video, we'll dive into how BGP works and how routes are chosen. Thank you.